And again, welcome to our today's class. And this now takes us back to a topic called vectors. That is question 17, and the question reads, in the trapezium shown below, vector PQ is equal to 3 vector ST. And the arrows on top of those vectors will give us more about the direction of those two vectors. And they've told us that T divides SR in the ratio 4:1. And U is the midpoint of QT. PU and QR intersect at X. And they've told us PX is equals to HPU and QX is equals to KQR. So I'm going first to look at that diagram and be able to give a brief description in terms of inserting that data into that diagram for us to make our work easier so that you can work out all those questions below that diagram. So you've been told that in the diagram given here, of course, which is a trapezium, PQ is equal to 3ST. So for you to get this PQ, you have to have 3 of this. So 3ST can give you PQ. I'm repeating, 3ST, 3 of this ST should give you PQ. So if they've given PQ as Q or vector Q, that means we are going to pick this vector, then divide by 3 for us to get ST, because 3 of this can give us this. So 3 of ST can give us PQ. And if PQ is Q, then that tells us that now we are going to get ST. Let me just write something here for you to see. You see, we can say that PQ is equals to 3ST. But we've been given PQ, remember? Our PQ is Q vector. So you can say Q vector is equals to 3ST. I'll divide both sides by 3 so that I can be able to get the ST vector. So that our ST vector is Q over 3, or you can just say a third Q vector. That makes our work easier. So that means from S to T is a third Q vector. Correct. Then they have said T, look at that, T divides SR. Look at that, in the ratio 4:1. So T is dividing SR in the ratio 4:1. That tells you that T is a point that divides line SR externally. I'm repeating. T is a point that divides SR externally. So we can have -1 here because the vector is vector SR. But that being a line, that line gets divided externally by a point T. And that point T divides that line SR externally in the ratio 4:1. So that smaller number, that other number, the next number that appears, which is 1, should have a negative. It's an external division. So the smaller number that comes after that first number should have a negative. Or you can just pick the smaller one and actually put a negative. Then let it be between the point that divides that line. So T is to the outside of SR. So it divides SR externally in the ratio 4:1. So you can put here -1. Then you can obviously have 4 here. Correct. Okay, and they're saying U is the midpoint of QT. So let's go to QT. So you have QT. QT has a point U, and that U is dividing that QT internally in the ratio 1:1. Why am I even saying 1:1? U is the midpoint of QT. So we shall have a half. Look at that. A half and a half. Midpoint means that U is dividing that line QT equally into equal parts. So a half, that gives you a whole number 1. As I was saying 1. So 1, 1, that means 1, 1, that means 1/2, 1/2. Correct. They have also told us that PU, look at that, PU, okay, and QR are able to meet at X. Okay, fine. The point of intersection of line PU and line QR is X. They have given us more information and told us that Px is HPu. Look at that. Px is HPu. So just put here H. For you to get Px, you pick the constant H times the whole vector Pu. You want to get Px, what do? You pick H, the constant, then multiply by the whole vector Pu. Okay. Then Qx is KQR. So that means if you put here K, that means K times the whole vector, you get Qx. I want to repeat. K is the constant, you multiply by the QR, you get Qx. Fine. And let's go to the questions now. Of course, you need to understand this, that vector PS is indicated P. So that's actually well catered for. They have told us, given that PQ is Q and PS is P, vector PQ is Q and vector PS is P. Express QR in terms of P and Q. You want to move from Q to R. What do? You'll say QR is equals to QP plus PS plus SR. You want to move from Q to R. You have to move along this route. So you'll say QP, PS, then SR. Let's begin. What is QP? You are going against the arrow because our PQ is what is Q. But now our QP will be negative Q. And we shall say plus PS. Our PS is P. Okay. Then what about our SR? Our SR is actually going to be, you see, you have to use what you call the vector aspect. So that means if the whole of this will actually represent a third Q, because we have been told here that PQ is 3ST. PQ is 3ST. So PQ, this PQ is 3ST. And the whole of this must have a total of, you'll say 4 plus negative 1. That gives you 3. So that means from here to here, the whole ratio is 3. So we can literally be able to say that just somewhere here, if 3 represents, look at that, 3 represents the whole of this, which is a third Q. What about 4, which represents SR? So 3, the whole of it, represents a third Q. What about 4? I guess you get the point. I guess you're getting the point. I guess you really get the point. So you're going to say, what about 4? So you can just cross multiply. So you'll have 4 times a third times 1 over 3. So that's going to be 4 times 1 times 1. Why am I even saying times 1 over 3? Because it's 4 times a third divided by a third. So that will be 4 times a third times 1 over 3. So that is 4 over 9. So it will be 4 over 9Q. So to collect the like terms, you can have 4 over 9Q less Q plus P. That is the same as 4 over 9Q minus, this is the whole number Q, which will be now 9 over 9Q. Then you'll say plus P. That is the same as saying negative 5 over 9Q plus P. So that is the same as P less, okay, 5 over 9Q.